Okay, so this is our review session for exam one. And I think the way I'm going to do this is I'm going to go through your exam one wrapper and I'm going to illustrate how I solve that problem, and then that will also be um, what I teach. Okay, so one of the things you need to be able to do is do conversions for the metric system. So you need to be able to convert. So on your exam wrapper, you have 22.04 milligrams. And you can see A, B, C, D, E, you have different conversions. So what I would do is always go from the prefix to your base unit. And so here, the base unit would be gram. And so milligram equals the base unit, and milli means 1,000. That's a big number with a small unit and one. So then you put milligram on bottom and gram, 1,000 and one. And so when you use your calculator now, you know to divide 22.04 divided by 1,000, and that gives you 0.02204 grams because the units cancel out. Now look and see if you see A, B, C, D, or E, and you see that you have 2.204 grams, which is D, and so that is incorrect. So you can go ahead and mark that out. That's not going to be the correct answer. And then you can then convert the grams to the different prefixes. And so the first one you can go, okay, so let's convert this to kilograms. So grams and kilograms. And then you're going to have to go, okay, there's 1,000 grams in 1 kilogram. And so then you put the 1 with kilograms, 1,000 with grams, and then you can divide by 1,000, and you get 0.12342204 kilograms because these cancel out. And as you see, that is answer A. So when you get your answer and you get the right units, you can move on to your next question. If that was not the correct answer, then you should take the grams, the base unit again, and then you would convert. The next one would be centigrams. So grams to centigrams. Centigrams is 100 into 1, and then that would be 2.204 centigrams. And as you can see, that doesn't work because in B is 2204 centigrams, so obviously that one's wrong. And you would go through each one of those from the base unit. Okay. Let's go to our next problem, which is how many significant figures? Okay, so significant figures, we've talked about this. You want to go over the rules. So one kind of question is when you're given a number, how many significant figures? And remember, you go from left to right, and when you see the zeros, zeros to the left of the decimal or of the number are insignificant, so we don't count them, not important. So you just go here and you see, okay, there's your number, and then you start counting, and you count all zeros in between numbers, and a number is 1 through 9, okay? And you count all zeros at the right of a number. So in this case, it is 3. And you see the answer is C. Okay, so one of the things you need to do is be able to do dimensional analysis. So here we have in 2004, 9.05 times 10 to the ninth pounds of sulfuric acid, and we're going to do naming, so you're going to have to know sulfuric acid, H2SO4, were produced in the United States. What was the mass? So this is your question. Mass in kilograms. Okay, and then you're given conversion factors. Conversion factors. And so 1 pound equals 453.6 grams. Now, this is your given. Given means that's where you start. 9.05 times 10 to the 9 pound. And you're going to put pound on bottom. Now, you can go from pound to gram. So what's your plan? Call it the conversion factor plan. Pound to gram. And then it asks for mass in kilogram. So can you go from gram to kilogram? You can. So what is that? That is 1,000 gram equal 1 kilogram. So then you can go from pound to gram. You put gram on top. You don't want gram, see, because you're going to go to kilogram. So you put that on bottom, and you put kilogram here. And now you can put your numbers in. 1 goes with pound. 453.6 goes with gram. 1,000 goes with gram, and 1 with kilogram. And you'll see that pounds cancel out, grams cancel out, and you're left with kilogram. So now you get your calculator, and you do 9.05 to the EE of 9 times 453.6 divided by 1,000. And so that's 410508000 kilograms. And then you double check that to make sure you have the right zeros. 1, 2, 3, 4. Okay, so there is the decimal. And sure enough, we're going to have to convert this to scientific notation, which is another thing you need to be able to do so you can find the right answer. And so here's the decimal. We're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 spaces. And it's a big number, so you need a positive exponent. And now you also want to check for you have 3 significant figures, so we want 3 significant figures. So 4.1, and then the 5 is going to round that up to 1. And then that's times 10 to the 9th kilogram. And you will see that that is answer D. The next problem is we have to round a number to a certain number of significant figures. So here we are given a number 0.004099950 milligrams. All right, so and it says round this number to 4 significant figures. So first you're going to have to go and find where the 4 are. Okay, so we don't count the zeros to the left, and then we have 1, 2, 3, 4. So there is where we want to go to. So when we look at this number here, so we're looking here, and the 9 is greater than or equal to 5, so we must round up. So we're going to round this number 9 up, but because that rounds up and that rounds up, it's going to end up going to 0.004. This will round to a 0. That rounds up to a 0, and that's going to round up to a 1. So those are significant. And you see that that answer is D. Okay. I noticed a lot of people missed this question on the online quiz. So you had your online quiz. And I would recommend you reread the question because it says the most precise, and this says but not accurate. So what a lot of people did, I noticed they got 27 out of 30 on their quiz. They picked the thing that was most precise and the most accurate. Okay, so here they're telling you what the reported density of gold is, 19.3 grams per centimeters cubed. So that's the accuracy. And so precise means how close the measurements are. And these are usually done with standard deviation, but you can see 18.203, 18.301, 18.299. They're all like a decimal to the 10th place, and but these are, a whole 1 unit away from the true value. So that's the answer B. If you look, 19.203, 19.301, 19.299. This is accurate. This is the most accurate because it's closer to the 19.3, but it's also the most precise. So that is both. And C is not accurate and not precise. Okay, so get out your periodic table and look at where sulfur is. So one of the things you need to be able to do is do numbers of neutrons, protons, and electrons, and the charges that these elements will take in a compound. Okay, so we have sulfur, and sulfur is S. And you look on the periodic table and you see that that is in group 6A. And 6A, that's a nonmetal. And so nonmetal are going to form negative charges. And it's 2 from the noble gases, so it's going to be sulfur 2 minus. And so, like, if you had a compound, which, like, sodium sulfide, now, the first element gets its name, sodium, and you look at where sodium is on the periodic table, and it's group 1, and that's a metal. It's an alkali metal, and it's in group 1A, group 1A, so it gets a +1 charge, and it gets its name. And sulfide is S2 minus. The I means it came from the periodic table. It's a nonmetal. This is an ionic compound. That means it forms a charge. Ionic includes a cation, see the word ion, and an anion, okay? Positive and negative, and they have to sum to 0. So sulfide is 2 minus, and I'm just kind of using this as a problem to show you a little bit of the naming, and you need to continue to study the naming. Okay, so then I do the crisscross, and those become the subscripts. So sodium is Na, and it gets a 2, and sulfide is S, and it would get a 1, so you don't put anything there. So that would be the formula, the chemical formula for sodium sulfide. And like I said, sulfur is a nonmetal, so it's going to adopt a negative charge, and it is 2 minus. And so when you see the charges, you see these in the compounds that they form. The other thing you need to be able to do is do formula weight with the sodium sulfide and percent mass of sodium and percent mass of sulfur. So since we do have a compound here, I will see if I can do this with you. I don't have my periodic table. Let's see if I can pull one up. And you'll be given your periodic table okay, so sodium, if you look at the average atomic mass, you see that that is 23, and that rounds gram per mole. And there's 2 of them. So sodium, there's 2 sodium because the subscript there, times 2 for sodium. And then sulfur, there's 1 sulfur. So if I look at sulfur, I see that this is 32.065 grams per mole. And so I do 2 times 23. That's 46.00 grams per mole for sodium. And so 46.00 plus 32.065, that's going to sum to 78.065 grams per mole. And so if I wanted percent mass by sodium, I would take the mass of sodium, the part of sodium over the whole of the compound, times 100%. So 46.00 gram per mole divided by 78.065 gram per mole times 100. And so 46 divided by 78.065 times 100, I get 58.93% sodium. And then you could do the same thing with sulfur. You will find, since there's two parts, that should work out. Percent sulfur would be 41.07% for sulfur. So that's another skill set that you need to be able to do for exam 1. All right, how about the next question? Number of protons, neutrons in phosphorus 35. You might see this is P35. That is the mass number. Okay, so the mass number is 35, and so the mass number equals the number of protons plus number of neutrons. So 35 equals P plus N, and now I need to look at the periodic table of phosphorus to see what number element that is. And I see that it's 15. So protons equal 15. So 35 equals 15 plus N. 35 minus 15 equals N. And I think that would be 35 minus 15 is 20. So 15 protons and 20 neutrons. And you see that take a little look and make sure that you get the P and the N in the right order. The answer is D. All right, so on. Which of the following ions is nitrate? Nitrate. All right, so this is naming. And so nitrate, remember the 8s. The 8s come from your memory. Remember ide? Ide comes from the periodic table. So anytime you get if you got sulfide, that means that's S2 minus, and it's a monoatomic, meaning only one element. These are your 8s. You need to know your 8s and your ides. You have to have that memorized. These are polyatomic. That means more than one. And the 8s and the ides are the elements, and they form with oxygen. Okay? So you need to know the number of oxygens, which is your subscript, and you need to know your charge that goes with that, and the name, because that's the only way you're going to know. So nitrate, and so I have this little mnemonic, Nick the camel, 8, see the 8, a clam supper in Phoenix. And so like Nick would be your nitrate, and the N, so the number of consonants equal the subscript for the number of oxygens, and the number of vowels in the word equal the charge. So Nick has 3 consonants, and it has 1 vowel, so 1 minus, and that's nitrate. And then you need to know that nitrite Then you decrease the number of oxygens by 1, and you keep the charge the same. And these are the ones you are responsible to memorize. So nitrite would be NO2 1 minus. Okay, camel is carbonate. And that's C. How many consonants? There's 3. How many vowels? There's 2. That's carbonate. What would carbonite be? I don't think you have a carbonite. You might. Actually, you do have carbonite. CO, drop the 3 to a 2 and maintain the charge. So these are the ones I do expect you to memorize. I know there's a list of them you can refer to in your book. Clam, Cl, that's chlorine with the oxygen. You have 3, 1, 2, 3 consonants. You have 1 vowel, so that's chlorate. Now I do expect several of these, so this one's going to be a little more challenging because I do expect you to do chlorite, but there's also 2 others. Then you got to go even lower, and you got to go hypo, right? Hypochlorite. So that means we're going to have to drop it again to O1, 1 minus. And then you have to go up from chlorate to chlorate. I don't think it's hyperchlorate. I don't have my book with me. Hyperchlorate. It's hypo, yeah. Hypochlorate, okay? And so hypochlorate, you're going to increase the 3 from 8 to 4, 1 minus, okay? Sulfur is sulfate. So sulfate is SO4, 2 minus. Sulfite would be SO3, 1 minus. And then Phoenix would be PO4, because you got 4, and then you got 3 vowels, so that's 3 minus, that's phosphate. And then you have phosphite. Now also in your book you'll see that it's not just Cl, you can get the same thing with bromate. These are your halogens, so bromate would follow the same pattern, and so would iodate. Iodate, this would be bromate. So those are your halogens when they form polyatomics with oxygens, and those I do expect you to know. While we're on the naming, let's go on with naming of acids. So you need to be able to name, so if you're going to name compounds like sodium phosphate. Okay, well sodium, the first element gets its name, Na, and it's a metal. So you're going to have to deal with charges. And sodium becomes +1 because it's in group 1A. And then phosphate, you had to memorize phosphate from Phoenix, PO4, 3 minus. And then so when you do the crisscross, you have 3 sodiums and you have 1 phosphate. And so that is the chemical formula for sodium phosphate. And you can do the math. It has to sum to 0. So you have 3 sodium times 1 charge, that's a +3 charge, and then phosphate has 1 phosphate times 3 minus is 3 minus, and a 3 plus and 3 minus sum to 0. So this crisscross works. Now, what about acids? So like if you have acids have hydrogen in front, okay? So these are acids, they can donate H+. And so your strong acids are like H2SO4, sulfuric acid. And so it comes from, you have to know that that's sulfate. So that's sulfate. Okay, you memorize that. And when you have hydrogen in front, that's when you need to go, oh, this is an acid. Remember, it's the first element. This is a metal. It's the first element. If you have H in front, then you need to follow the acid rules. And so that means you look here, you see that sulfate, and H's become ic acid. They get the word ic acid. We drop the H, we add ic acid. So you see how you went from sulfate to ic acid. And so there's and we have to have two of them because it's an H plus charge. And so if you have H plus and you have SO4 2 minus and you do your crisscross, you see that you need to just sum to 0. And that's how you get sulfuric acid. Okay, what about phosphoric acid? Okay, well, you realize that you have an acid, so you're going to have an H plus first, and this is ic acid, so it comes from the 8. So you got to think, what is phosphate? And then you need to think maybe, okay, phoenix, right? So it's PO4 3 minus, and then you can do your crisscross, and you see that you need 3 H's PO4, and that's phosphoric acid. All right, let's do another one. There's nitric acid. Nitric acid. Okay, ic acid comes from 8, and acid means we got to have an H plus. Okay, so what is nitrate? That would be from Nick, and that is NO3 1 minus. And so then when you do your crisscross, HNO3. So that is nitric acid. Nitric acid. Now, you also need to know your US acids. Okay, so US acid, nitrous acid. Once again, it's an H plus, but you got to recognize nitrous comes from ic, or it comes from ite. Ite. Okay, so what is nitrite? Well, nitrite is you drop the oxygen count to 2, 1 minus. So US acid comes from ite, nitrite, and then when you do your crisscross, you see that this is HNO2, and that's nitrous acid. So US comes from ite, ic acid comes from 8, and you need to be able to do these with your polyatomics. Now, what about hydrochloric acid? You've probably heard of this before. Okay, anytime you have hydro, it comes, so you have an acid, right? H plus, it's acid. But whenever you have the word hydro in front of it, this is monoatomic. This came from the periodic table. So that means you just pick chloride. It came from chloride. It came from the ides. Okay, and then you do that, and you get hydrochloric is HCl. So if you have hydrobromic acid, well, it's acid, so you need H plus, and then you got to think, okay, hydro means it came from the periodic table, which is an ide, and that means Br 1 minus, and that's HBr. So that's hydrobromic acid. Keeping on with the numbering and the naming, let's just do some other examples of a nonmetal with a nonmetal. We don't do charges, so like if you have something like CCl4, this is carbon and tetra, because that means we have 4 chloride. And so that the first element is a nonmetal, and we need to do prefixes. I told you in class you need to know mono, di, tri, tetra, penta. So you need 1, 2, 3, 4, 5, and these are based on the subscript. So you all have heard of carbon monoxide, carbon monoxide. So whenever you have two vowels together, you usually drop the A. So you do put the mono for the second element, you don't for the first one. So this one's carbon dioxide. And so that's the naming for that. And then the other naming you have is if you have transition metals. So if your first element is like, so iron, well, okay, so let's do this one. Okay, so if you have to convert that to a name. So you would see that Fe is iron, and you see that it's a transition metal, so you know you need to have a Roman numeral. And that Roman numeral is going to be your charge. So the way you figure that out is you got to look to the anion, and you know that Cl is in group 7, so that's 7A, so it's a 1 minus, and you see that you have 3 of them. So your total anion charge, the negative charge, is -3. So this has to sum to 0, so you're going to do -3, these are going to be absolute value signs, by the subscript with your transition metal. In this case it's 1, right? So 1, so -3 divided by 1 is -3, and absolute value sign of that is +3. So that tells you that the charge on the iron is going to be 3. And then that's iron 3. And then this comes from the periodic table, it's just chloride. So then if you have to convert a name, like copper to oxide, to a chemical formula, the Roman numeral is the charge, so you just do copper 2 plus, and then oxide comes from the periodic table, 2 minus, and so this crisscross, that would be copper oxide. And because the 2's cancel out, because this is a 2 plus and a 2 minus, you only need 1. That's a 0. What about if you have something like, okay, how about iron to phosphate? Because well, here you have to remember phosphate is PO4 3 minus, because that's an 8. And now you know that iron is going to be a 2 plus charge. Okay, so then we're going to do the crisscross for the subscripts. So iron now becomes a 3, and sulfate is a 2, and this is a polyatomic, so now we need parentheses, folks. So you're going to put the parentheses, and then you're going to put the PO4 inside your parentheses, and then you're going to put the 2 on the outside of the parentheses. And that means if you were to do the formula mass of this, formula mass, you would take 3 times the formula mass of iron, which, I have to look on my periodic table, (55.845 grams per mole). You would have 2, so that's iron. For phosphorus, you would have 2 times 1, so there would be 2 phosphorus. (30.974 grams per mole). And you would have 4 times 2 oxygens, that's 8. Well, oxygens, so 8 times 16 grams per mole, and you would add all those up to get your formula mass, and that's why you have to have the parentheses. All right, so that's naming I did a long review on naming. So let's see if you can figure out question number 9. What is sulfuric acid? And so sulfuric acid, ic acid comes from sulfate. And sulfate is SO4 2 minus, and sulfuric acid H plus, so that would be H2 SO4, and that answer then would be B. Okay, what is the correct name of Fe3PO4 2? And Fe is iron. Okay, so here we got to remember, okay, Phoenix, so these are polyatomics, PO, 1, 2, 3, 4, 3 minus. So this is PO4, so this is obviously phosphate. Phosphate, it has a 3 minus charge, so PO4, 3 minus. And then iron, we don't know what the iron charge is. Iron is a transition metal, so I need Roman numeral in the parentheses, and that's the charge. So this is going to be iron parentheses, and I don't know what that is yet. I have to figure out what is my total negative charge. So I'm going to do my total negative charge on top. I'm going to divide by my subscript number of my transition metal. I'm going to take the absolute value sign of that. So if I have -3 and I have 2 of those, 2 times -3 is -6. So this is -6, absolute value sign, and then the 3 subscript is that. So 6 divided by 3 is -2, and then that's going to be a +2 because it's on the positive. So there is going to be iron to phosphate, and that answer is D. Okay, so practice naming, work your problems, and your suggested problems. Okay, what is the numerical result when you perform the following calculation? So this is 6.77 parentheses times 9.25 minus 12.335 divided by 4.557. Now, you have to do parentheses first, so we're going to do parentheses within the parentheses. So we're going to do this first. So 9.25 minus 12.335 is -3.085. And then that has the significant figures rules for addition and subtraction is 2 to the right of the decimal. So this has 2 and this has 3. So the least number is 2, so I need to round this to -3.09, and so that gives me that parentheses, and now I've got to take this times 6.77, and then I'm going to divide that by 4.557. So now this is my parentheses, and this is a multiplication. This is just a negative number. So I'm going to do 6.77 times -3.09, and I get a -20.9193. And since this is multiplication and division, it's the least number of significant figures overall. So this is 3 significant figures, and this is 3 significant figures. So this needs to be -20.9, because the 1 will leave it the same, divided by 4.557. So -20.9 divided by 4.557, I get a -4.5863506669. And then since this is division, I'm going to do 3 significant figures versus 4 significant figures. 3 is the least number overall, and that's going to round to 4.58 or 4.59, -4.59. So I think I had some rounding issues here, because when I look at that, I see that the closest answer is D, 4.58. So that's the answer I'm going to go with. Probably what happened is if you don't actually round these, so if you just do it 9.25 minus 12.335, and then you take that number without doing the rounding, 6.77, equal that out, divided by 4.557, you get an answer. This is your answer, negative 4.583157779. And if you do it that way, you see then you have to come here and go, okay, there's two significant figures for this to the right, and you have to still do your, and that would round to 4.58. So, number 12. Okay, so one of the things you need to be able to do is mass percentage of oxygen in phosphoric acid, and the formula is given to you. So this is going to be the part of oxygen over the whole of the compound, and that's going to be times 100%. And so we've got to figure out the formula weight of the compound. So there's 3 hydrogens times 1.008 grams per mole. We have 1 phosphorus, and I have to look at that on the periodic table, and that is times 30.974 grams per mole, and then we have 4 oxygens times 16 grams per mole. So when you do the math there, you see 3 times 1.008, that is 3.024. You have 30.974, and then 4 times 16 is 64. And if you add all that up, you get 97.998 grams per mole. And it asks for the part of oxygen. So I've got to do the oxygen, which is here, 64 grams per mole, divided by 97.998 grams per mole times 100%. So now 64 divided by 97.998 times 100, I get 65.31%. And that is answer E. Okay, 13 is more naming. So I'm not going to go over that anymore. So you can work that because due to time. Let's do 14. Okay, so 14 is, what is the mass percent of chlorine in PCl3? I think I know how, I showed you how to do that. You do the mass of the chlorine over the mass of your compound, which is PCl3 times 100%. So you should be able to do that. Let's go with number 15. Which of the following is classified as a halogen on the periodic table? So you should be able to do that. Bromine is the halogen. So you have labeled your periodic table, so be able to pick out an element according to the alkali metals on group 1A, and they form +1 charge. Then you have the alkaline earth metals. That's group 2A. They form +2 charges. And then you have all this here. This is the transition metals, and they have a variable charge, so it's like a Roman numeral in a parentheses when they form compounds. And then over here you have the stair step, which is the metalloids. These are metals, and then over on this other side are the non-metals, and they tend to form either covalent compounds, so you're dealing with prefixes in the naming if they're the first, or if they're in an ionic compound, they're going to form a negative charge. And so you have the halogens that are group 7A, and the group 8A do not form in compounds. They are the noble gases, and that's the last ones on the periodic table. Okay, you should be able to do 16. We're on the open response now. So we've gone over significant figures and calculations. We've gone over naming. And then fill in the gaps of the periodic, the protons, neutrons, and electrons. You should be able to do that. Dimensional analysis. What is the molecular mass for sulfur dioxide? So you should be able to do that. More dimensional analysis. I think that question 21 is the same question as your multiple choice question. Rounding to significant figures, we've gone over that. Assigning elements in the periodic table. So there's one other thing I would like to show you before we stop. So here's this. Okay, what if you were given a compound that is, let's say, 35.52% oxygen, and so what if you were given something like this? Okay, so if you have, I'm making the problem up now, okay? So sometimes you're given the percentages, and I want to show you how to do that. 4.48% hydrogen, and 60.00% carbon. So this is the other problem that you could get for percent composition. And so what you want to do, step one, you want to convert the percent to gram per mole. So you're just changing units and you don't have to do anything special. So let's just do that, 35.52 gram per mole of oxygen, 4.48 gram per mole of hydrogen, 60.00 gram per mole of carbon. And then step two, you have to do dimensional analysis and you got to convert grams to mole, from moles to mole of element. Okay, so our goal is to get the chemical formula, and that means we need the subscripts. So I'm trying to get the subscripts because this is going to be carbon something, hydrogen something, oxygen something, and I don't know what the X, Y, and the Z are, and sometimes you can get percents like that. So step one, you just change the percentage to grams per mole, and then step two, we're going to use the periodic table with their masses, their grams per mole, their molar mass, to get the subscripts. So in this case, you would do 35.52 grams over 1 mole of oxygen, and then gram of oxygen for 1 mole. Okay, and you would look at the periodic table and you'd see this is 16 for 1 mole. And so now you would take 35.52 divided by 16. And that's 2.22 mole for oxygen. And then you would do the same thing for each one of them. So now do 4.48 gram over 1 mole of hydrogen, and then 1.008 gram of hydrogen for 1 mole of hydrogen. And so that would be 4.48 divided by 1.008. That gives you 4.4444 mole of hydrogen. And then you got to do the next one, which is 60 gram of carbon over 1 mole of carbon, And then you look at the periodic table and you see that's 12.01 gram of carbon for 1 mole of carbon. And so you do 60 divided by 12.01, and that's 4.9958 mole of carbon. And now you want to do step 3. This is the last step. Step 3, you're going to find the subscripts. And how you do that, remember these got to be whole numbers. So you want to take the numbers that you just calculated here, the moles, and divide by the lowest number of moles. So 2.2 is it, right? That's smaller than 4.4 and 4.9. Excuse me. And you got to divide each one by this. Well, 2.2 equals 1 mole of oxygen. All right. Well, 4.4444 divided by 2.22 is 2.00 mole of hydrogen. And you can't round on this. No rounding. So this has to, the second number, this is 1.0000. The second number has to either be, this number has to be either a 0 or a 9. Okay? So 0, second number has to be 0 or a 9 for it to be like a whole number. All right, so let's do the next one, and you're going to see the problem with that. 4.9958 divided by 2.22. Now you get a 2. You get a 2.25. Okay, you cannot round that. You see that this number is not a 0 or a 9, so you can't round that. So now you're going to have to multiply each one of these by a number to get a whole number. So like the problem is 25. So you can do 2.25 times 2, that gives you 4.5. So this is where you got to kind of think. So if you take 2.25 times 2, that gives you 4.5. Well, that's a problem. You still can't round. So now you can take 2.25 times 3. 2.25 times 3, that gives you 6.75. That's still not a 0 or 9. So now you're going to have to take 2.25 times 4. 2.25 times 4, and you get 9. 9 is a whole number. So now you know what your number is, 4. So now 2.25 times 4, that's carbon, and so the number is 9. But now you're going to have to multiply all of these by 4. So now you got to do, for hydrogen, you got to do 2.00 times 4, which is going to be 8. So hydrogen is 8. And then you've got to do oxygen, which is 1.00 times 4. And now that's 4. So then oxygen is 4. And if you look at that, what is the formula for aspirin? Number 25. C9H8O4. So that's just an example as if you're giving percentages. And you might have some of that on your homework, and you might have it on your exam. But if you're given percentages, you have to find those subscripts. And that is another skill you need to be able to do. The other thing that I haven't reviewed on this, and that I do know you need to be able to do, is calculating the average atomic mass. So, but due to time, I'm gonna call it average atomic mass. So you basically take the atomic mass unit times the percent abundance for each isotope. So you might be given like isotope X with a certain atomic mass unit, Y and Z, and you've got to add each one of these together. You would be given the numbers. I don't have a problem per se to work. that you can find these in your book. So you know how to do that, work a few problems. And so this gives you one number. This is how you get the mass number on the periodic table. It's actually the average atomic mass, and it takes into consideration the relative abundance of each isotope. And if you remember, an isotope has the same number of protons, but different number of neutrons, so it has a different mass. And that is another mathematical thing that you should be able to do. This wraps up this review session.